Welcome to the solutions video for AP Calculus section 2.3b. We're on page 121. We're going to do 27 through 41 odd, 47 through 57 odd, 65 and 67. This video will probably take me longer to do than the lecture video did. But I was able to cram the solutions of the first 1, 2, 3, 4, 5, 6, 7 on the board here. So for 27, we're going to use the product rule. It's t squared times sine t. So it's the first, t squared, times the derivative of sine, which is cosine, plus the second, sine, times the derivative of t squared, which is 2t. And you want to put the 2t out front so that you don't think 2t is part of the angle. So it is better to bring that out front in terms of formatting. All right, 29, we've got cosine t over 2. We're going to use the quotient rule. So it's the bottom, t, times the derivative of cosine t, which is negative sine t, minus the top, cosine t, times the derivative of the bottom, which is 1, all over the bottom squared, t squared. We could bring the negative out front and make it negative t sine t, but otherwise there's not really much you need to do there. All right, don't need that. Okay, 31, we have f of x is negative x plus tangent x. So f prime of x, the derivative of negative x is negative 1. Derivative of tangent is secant squared. It should be negative 1 plus secant squared x. All right, 33, g of t is root t plus 4 secant t. We could rewrite that as t to the 1/2. And then the derivative is 1/2 t to the minus 1/2. We're going to clean that up in a minute. And the derivative of secant is secant times tangent. So 4 times secant times tangent. Cleaning this up and making the exponent positive, I'd have 1 over 2 times the square root of t plus 4 secant t tangent t. All right, 35, we have y is equal to 5x cosecant x. So y prime would be the first, 5x, times the derivative of cosecant x, which is minus cosecant x cotangent x, plus the second, cosecant x, times the derivative of the first, which would just be 5. All right, so it's better to bring the 5 out front so we don't confuse it with the angle there. All right, 37, y is equal to minus cosecant x minus cotangent x. So the derivative of minus cosecant x would be minus cosecant cotangent x, and the derivative of sine is negative cosine, or excuse me, is cosine, so that would be minus cosine x. I am going to go ahead and make the two minuses into a plus, and that's good enough. And then 39, we have y is equal to x squared sine x plus 2x cosine x. So we've got the first, x squared times the derivative of the second, which would be cosine x, plus the second, sine x, times the derivative of the first, that's 2x. And again, I brought that 2x out front. And then plus the first 2x times the derivative of cosine, that's negative sine, plus the second cosine times the derivative of the first, which is 2. Now, you might see here that 2x sine x, and then you have a negative 2x sine x here. That goes away. I do expect you to go ahead and cross those two out and give me a final answer of x squared cosine x plus 2 cosine x. All right. Okay, number C, that was 39, right? So 41. We have f of x equals x squared tangent x. So f prime of x, product rule of the first, x squared times the derivative of the second, secant squared x, plus the second, tangent x, times the derivative of x squared, which would be 2x. I'm going to put that out front. And that is good enough. Okay, now things get a little fancier for a few of these. So 47, we have y is equal to 1 plus cosecant x over 1 minus cosecant x. And we want to evaluate the derivative, and the point is going to be pi over 6 negative 3. But we really only care about pi over 6. We're gonna plug that into the x value after. So the derivative, y prime, is the bottom, 1 minus cosecant x, times the derivative of the top. Well, the derivative of 1 is 0. The derivative of cosecant is minus cosecant x cotangent x. All right, so that's the bottom times the derivative of the top, minus the top, 1 plus cosecant x, times the derivative of the bottom. Well, the derivative of 1 is 0. The derivative of minus cosecant x would be just positive cosecant x cotangent x, all over the bottom squared. Now, I'm not going to FOIL all those out and try to clean all that up. I'm just going to go ahead and plug in a pi over 6 now. Okay, but let's figure out, I've got cosecants and cotangents. So the cosecant of pi over 6, all right, well, cosecant goes with sine. The sine of pi over 6 is a half. So the cosecant of pi over 6, you're going to flip that, is 2. All right, and then the cotangent of pi over 6 is equal to the cosine over the sine. So cosine of pi over 6 over the sine of pi over 6. So this is a really good unit circle exercise here. That's going to be root 3 over 2 divided by a half, which is root 3. So now I've got the cosecant of pi over 6 is 2, and the cotangent of pi over 6 is root 3. Now I'm going to plug all that in. So y prime of pi over 6, that's 1 minus 2 times negative 2 times the square root of 3 minus 1 plus 2, cosecant is 2, times positive 2 times the square root of 3, all over 1 minus 2 squared. Okay, that's going to be negative 1 times negative 2. So that's on the top. These two multiplied together would be positive 2 times root 3 minus 3 times 2 is 6. So minus 6 times the square root of 3 all over negative 1 squared, which is 1. So that's going to be negative 4 times the square root of 3. All right, beautiful, but yeah, a little bit of a pain in the butt. If you got the derivative right, then you should feel good about that. If you messed up on the plugging in, hey, you just got to be careful on that. But you can do it. All right, 49 h of t is equal to secant t over t. So the derivative of this one is going to be a little easier than the last one. H prime of t, bottom t, times the derivative of the top, secant t, tangent t, minus, I'm going to go ahead and put that up here, negative 4 root 3. All right, bottom times the derivative of the top, minus the top, secant t, times the derivative of the bottom, which is just 1, all over t squared. Now we want to evaluate this at the point pi, negative 1 over pi, but we're not getting a tangent line or anything. We're just plugging pi in for t. Okay, so h prime of pi is equal to pi. So what is the secant of pi. Well, secant goes with cosine. Cosine of pi is equal to -1. So the secant of pi would be 1 over -1, which is also -1. So secant of pi is -1. Tangent of pi would be the sine of pi over the cosine of pi. The sine of pi is 0. The cosine of pi is -1, so that's 0. So I can put them up here. Pi, -1, 0, and then we would have a -1, and down here is going to be pi for t, so pi squared. So pi times -1 times 0 minus -1 over pi squared, and that's going to be a positive. Minus minus makes a positive 1 over pi squared. So again, a really good exercise, of handling the tedium of all of this plugging in and making sure that you get the proper value with the trigonometry there. So good problem. I recognize there is a bit of tedium with these. Okay, let's do 51. This time we have to get a tangent line equation. We have f of x is equal to x over x minus 1, so f prime of x, bottom, x minus 1 times the derivative of the top, that's just 1, minus the top, x times the derivative of the bottom, also 1, all over x minus 1 all squared. I'm going to go ahead, we can get rid of that x, can't we? And I just have -1 over x minus 1 all squared. So we need to get the slope. That's going to be f prime at 2, right? We're going to plug in that 2 value for x because the point is 2, 2. And that's going to be -1 over 2 minus 1, 1 squared over 1. So the slope is indeed -1. Okay, so now we're going to put it in the tangent line equation. So that's going to be y minus 2 is equal to the slope -1 times x minus 2. I am totally fine with that. The back of the book probably puts it in slope-intercept form, so if you solve for y, it's y is equal to -x plus 4. All right? So that is that's probably what the book does. Okay, 53. We have f of x is equal to x cubed minus 3x plus 1 times x plus 2, and we're at the point 1, -3. So f prime of x, I'm going to product rule this, the first, x cubed minus 3x plus 1 times the derivative of the second, that's just 1, plus the second, x plus 2, times the derivative of the first, 3x squared minus 3. And I'm not going to try to simplify all that out because I'm just going to plug in 1 to get the slope. So that's going to be 1 cubed is 1, minus 3 times 1 is 3, plus 1, plus 1 plus 2 is 3, and then that'd be 3 minus 3 is 0. So the 1 minus 3 is -2 plus 1, -1, and that is the slope. So our tangent line equation is y minus -3 is equal to -1 times x minus 1. So that's y plus 3 is equal to -1 times x minus 1. On a test, I am totally fine with that. I do want you to do the two negatives, make that a positive. If you're solving for y, shoot that 3 over to the other side and make it negative. It's going to be y is equal to negative x minus 2. So probably what the book has. Okay, these problems a little more tedious, but good problems to see if you can make it all the way through one of these longer problems. For sure, you will have ones like this on the test, where you have to get the tangent line equation. All right, let's take a look at 55. So that's f of x equals tangent x. And our point is pi over 4, 1. So f prime of x, it's going to be secant squared x. So the secant of pi over 4, the cosine of pi over 4 is root 2 over 2. So the secant would be the reciprocal of that, root 2 over root 2. So f prime of pi over 4 is going to be 2 over root 2, but you have to square that, all squared. So that's 4 over 2, which is 2. And that is our slope. So we have y minus 1, plugging these in now, y minus y1 is equal to 2, which is the slope, times x minus pi over 4. Lovely. All right, and then if you solve for y, you just add 1 to the right side, and that's going to be y is equal to 2x minus pi over 2 plus 1, but goodness, I don't think that's, I think this is better than that. Okay, 57. We want to determine at the point which we have a horizontal tangent. Okay, very good problem. F of x is equal to x squared over x minus 1. We know we have to get the derivative. Bottom, x minus 1 times the derivative of the top, 2x, minus the top, x squared, times the derivative of the bottom, which is just 1, all over the bottom squared. Now, I've got to set this thing equal to 0 because slope is equal to 0. That's where we're trying to find that's a horizontal line. So really what I want to do is clean this up. That's going to be 2x squared minus 2x minus x squared over x minus 1 all squared. And that's going to be x squared minus 2x over x minus 1 all squared. Now, we're going to set that equal to 0. But a little bit of a trick here. I don't care about the denominator. Where this is equal to 0 is where the numerator is equal to 0. We don't care about where the denominator equals 0 because it's undefined there. Okay? Where does the numerator equal 0? That will make this function 0. So all we have to do is set x squared minus 2x, the numerator, equal to 0. We can factor out of x. And then x is equal to 0 and 2. Those are our x values. To get your y value, we got to plug into the original equation. So plug into f of x. So when x is 0, f of x is also 0. So one point would be 0, 0. If you plug 0 in up here, that'd be 0 over negative 1, that's 0. When x is 2, plug in a 2 up here, that's 4 over 1. The y value is 4. So those are the 2 points where this curve, whatever it is, right, has a horizontal tangent line. Okay, another really good problem, especially recognizing, and you'll see this again in the future, you care about where the numerator is 0 when you're trying to figure out where does that function equal to 0. Okay, 2 more to do. So 65, we have C is equal to 100 times 200 over x squared plus x over x plus 30. And we want to know the rate of change. That's just take the derivative. So I'm going to go ahead and 100 times 200 that's 20,000, right? Just to make sure. Yeah, 20,000. So we have 20,000 over x squared plus 100x over x plus 30. So that's going to be 20,000 x to the minus 2 plus 100x over x plus 30. Now I'm going to take the derivative. That'd be minus 40,000 x to the minus 3 plus the bottom x plus 30 times the derivative of the top 100 minus the top 100x times the derivative of the bottom, which would just be 1, all over x plus 30 all squared. Okay, so C prime of, all right, we've got to do this in, we've got to do it for 10, 15, and 20. So C prime of 10 would be negative 40,000 over, and I'm going to bring this x underneath, that'd be over x cubed, so over 10 cubed plus 10 plus 30 is 40 times 100 minus 100 times 10 over 40 squared. Now you put all that in your calculator and you're going to get negative 38.125, and that's dollars. Okay, that's C prime of 10. Now, without writing all this again, if you put in 15 for x, if your calculator or your fingers don't betray you, it's negative 1042. And if you put in 20, it's negative 380. I don't know what's the right thing to do. Do I put the negative sign outside the dollar sign or inside? I don't really care. Okay, so what conclusion can you draw? These are order sizes, so bigger order size reduces the cost. Okay, so that's also part of the answer, and then these two are part of the answer. Okay, so on that one, taking the derivative is not so bad, but you could easily, it's tedious to plug those values in and not make a mistake. So you just got to be careful, go slow. Finally, number 67, we have P of t is equal to 500 times 1 plus 4t over 50 plus t squared. Okay, let's go ahead and distribute the 500. So that would be 500 plus 2000t over 50 plus t squared. So to get a rate of change, we're going to take a derivative. Derivative of 500 is 0. So we've got the bottom, 50 plus t squared, times the derivative of the top, 2,000 minus the top, 2,000t, times the derivative of the bottom, 2t, all over 50 plus t squared, all squared. So what are we plugging in? We want to find the rate the population is growing at 2. So that's 50 plus 2 squared, that'd be 54 times 2,000 minus, okay, that's going to be 4,000 times 4. Okay, 4,000 times 4. So minus 16,000 over 54 squared. All right, so if you don't mess anything up there, you should get 31.55 per hour. So that's 31.55 bacteria per hour growth rate at 2 hours. All right, that does it for this this video. Hopefully you didn't miss all of them and you only had to watch a few of these. And I'll talk to you next lecture.